All right, I think that might be everyone. I don't see anybody else joining right now. Any answer? What do you think it's about? What does it incorporate? What do you guys think it is? For example, let me try to get an example. Like gears, right? These are, you can think of them as the mechanical section of the thing. If I just keep them by themselves, they're not moving. But once I incorporate the electrical side of this, once I connect like something like a motor to it, then now this is where we get to electrical engineering. So electrical engineering is an engineering discipline concerned with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. Okay, so now we're gonna talk about mechanical concepts. So a lot of this workshop is just going into like the mechanical part of robotics. So we're going to be talking about like different systems, different types of machines that are used commonly. So what are certain devices that can convert energy into motion, any type of energy? Just name some. Yeah, motors, right? Basically, we power electricity to it and then the motor spins. So these are just a few examples. As you can see, there's a DC motors, and this is what a linear actuator is. This is what spews out the filament, the plastic, moves along this linear motion, right? And then there's also the main purpose of the lever involves mechanical advantage, which is the ratio between the amount of force produced, then the output force is less mechanically advantageous, but you're moving a shorter distance. So for our first class lever, the fulcrum is in between the effort arm, that's where the effort is being applied, and the load arm, right? So that's the first class lever. You can, a common example of that is like a seesaw, right? But if we apply a force, an input force, an effort force farther away from the fulcrum, second class levers, however, are always mechanically advantageous, right? And since the load is always in the middle, that means the effort is always farther away from the fulcrum than the load is. So you always apply less force for a greater output force. Certain things are certain ways, like why do you have to apply more force, a greater or less of a distance, or anything like that?
So can you give us another example of a third class lever? Because I still kind of don't understand it.
So do you get the bicep image? Or let me think of another third class lever. Okay. Let me try to explain it more. Have you ever like the farther you are away from the point that pivots, like the rotating point, since I'm moving a greater distance, I apply, let's say I apply like 5 newtons of force, right? Across this huge distance. Since I'm moving a greater distance, I'm applying a greater amount of force across that whole distance. So this is just color coded. So the load is on the left, the effort is on the right, and then the fulcrum is in the middle. So what type of lever is it? What do you guys think? First class. Okay, good job, good job. So let's check, see if we're right. Okay, boom, we're right. Now, mechanical advantage. Okay, you think it's a mechanical advantage? Why do you think it's a mechanical advantage? That's good, exactly, right? So I agree with Isaac too. I think it's neutral. The reason being is both of them are the same distance away. In order for the first class lever to be mechanically advantageous, right? Remember in the slide, it said sometimes it's also only mechanically advantageous. The effort has to be farther away. In this case, it looks like they're the same distance away. So that would mean it's a perfect system and there's no like friction or whatever like that. Okay, good job, guys. So let's just see if we're right. Okay, that we're right. Have you guys picked up a wheelbarrow before? It's like really easy, right? You can have like a bunch of dirt in it, but it's not too heavy. Okay, okay. I think everyone's got a hang of it now. Okay. All right, okay. This one's easy too. What type is it? Okay, Isaac knows his stuff. Okay, type. Okay, this one's also easy. Yup. Good job, guys. Okay, last. Oh no, last two. Which one is this? Efforts in the middle. I don't know what I wrote. Okay, but basically, the farther away you are from the fulcrum, you guys can get a little bit of a hang of it. So the first question is, I don't have an online whiteboard. Okay, so basically, let's just write out all their values. You can see, I'll make it bigger. Okay, so I don't think I 5 kilograms. Okay, so let me go on to the next slide. So kilogram is not a is a unit of mass, not force. So it gave us 5 kilograms, but is this a unit of force? What's a unit of force? If you guys know, there's nine, and the acceleration is 9.8, right? Because we're on Earth. I would need how do 49 newtons of force to newtons, right? So I'll convert this one to newtons. So I'm gonna times it by 9.8. Okay, yeah, that's better. Force one equals force two divide times distance two over d1. And we get force two, which is 49 newtons times 10 meters divided by 10 meters. So that just makes sense. Okay, so let's see if I'm right. Just got a piece of paper out and remember that this is 17 kilograms. So let's read the second part of the question. So how much would the load move if the force 944, that's a 4, 944 newtons, D1. So I guess I want you guys to try that out real quick. F1, F2, but we don't know D2. So when one gear turns, it makes the other gear turn too, but in the opposite direction. And it also mentioned it can either make it move faster or slower. That's the spur gear. There's bevel gears, this one right here, which is basically a is when you wanna, so this example here with 50 teeth to 25 teeth. So the teeth of the driven gear, so it's 1 to 2. So basically, if I move the big gear once, how many times is the other gear gonna rotate? So it's 3 to 1. So 45 over 15, 3/1. So now if I rotate the driver gear 12 times, how many times am I gonna rotate the driven gear? 3/2. Yep. So I rotate that small gear 3 times. I rotate the driven gear 2 times. Okay, a little bit harder. I rotate the driver gear 82 times. How many times does the driven gear, the bigger gear, rotate? So since it is the bigger gear, it should rotate less because it has more teeth. Oh, okay. Next one. You got the big gear. You got the driver gear being 75 and the driven gear being 45. Wait. Okay, then that one might be wrong. Though. Let's check it back. 75 over 45. So I know we know the answer, but like, let's try to solve it, right? So 82 times 3 divided by 5. So it's 49.2. Connect a bigger gear to a smaller gear. For one rotation, it can lead to more than one rotation of the smaller gear, dependent on what you're connecting it to. So this is a cool example. So let's say you got this big gear, right? But since it's a compound gear, it connects another smaller gear to it. This makes sure that this ratio of the idle gear. So how I kind of like thinking of this is I kind of like getting. So what would happen if I made this a 2? How would this number change? So it lets you stop and start motion without turning the motor off. So the motor just keeps spinning, but actually engaging that motor, actually making it move something, depends on if you engage that wheel. So example of like a clutch in a car, there's a flywheel and it just keeps pushing or it just keeps spinning, right? And then there's this mechanism right here that once you connect to it, locking the other way. Really good example of this is a zip tie, right? I don't have one on me, but a zip tie basically has these little grooves like this. What to learn to do robotics. So this was really just a really beginner lesson. There's certain like involves implying these principles to actually what's it called?
Yeah, good day. Sir, I would just like to ask, where do we integrate the software in those?
Like I talked about this at the start, but basically robotics is a combination of mechanical engineering, electrical engineering, and programming, right? You might have all these mechanical parts, but they can't move like if you don't connect them to anything, right? So for example, if you connect it to a motor, you can program that motor to spin. So let's say you want the robot to move forward, right? You might have a set of gears connecting the motor to a wheel. So that's a good way of applying it. If you actually want to get into Lego League, right? That's a place where you can get a lot of like knowledge from. But if you don't have that opportunity, so I don't have a picture. Let me try to. I don't have a picture of my robot, but yeah, you can use PCBs. Like for example, an Arduino is technically like you can actually make your own Arduino board if you make the PCB for it and then just connect the specific chip to it. So yeah, that's a PCB. Anything else? You guys have any questions about how to get into robotics, what to do specifically for mechanical, maybe to accomplish a specific task, if that kind of makes sense. And to learn it, I think if you're in like an isolated place, there are probably courses online. But if you just want to get into CAD or computer aided design, like initially, I would think YouTube videos are really helpful. But honestly, just start building something, right? Like think of a project you want to make, like for example, a robotic car or a little RC car, and then just figure it out and then just try to attempt to build it and then learn along the way. I think that's the best. Like learning as you go along is really helpful. Any other questions or I mean it's 7:10, so it's about to end. But what are you guys into? Like, what are you guys into right now? Like programming, what are you guys into?
you've ever seen those videos where there's like these competitions where they control this robot and picks up these rings and like puts them somewhere?
Any last questions? I'll give you guys like 10 seconds. Email me, I'll give you some advice if you want. And I hope you guys have a great rest of your day. And hopefully we see each other during the hackathon if you guys are doing that too. My partner.
Wait, quick question. Where do I find
Yeah.
more information about the hackathon? Well, I didn't actually sign up for this. I just got like a random email to join the workshop. So I did.
The hackathon, I'm just like doing a workshop, but I can try to find you. I think they have a dev post, like, and then I also asked them, how do I go on dev post? Um, yeah, just give me 1 second. I think, I mean, I did the hackathon like a few years ago, like I organized it like last year. But in terms of pairing, you can work solo or you can work by yourself. You can also ask people if you want to work together or not. It's up to you, right? If you want to work with a partner, you can work with a partner. If you don't know anyone, you can try to look for a partner or you can work on your own. It's whatever. I'm pretty sure that's how they're doing it this year. I'm not sure. I'm not on the organizing team. But yeah. So where do I go look for one? Like look for a partner on like the server or whatever. I don't know if yeah, they're doing it on WhatsApp now. But basically on like the community group chat, like, hey, does anybody want to pair up with me or something like that? You can also ask on DevPost. Like if you join through DevPost, yeah, you're gonna ask people like, hey, do you want to pair up or something like that? So that's let's you if you want to like be a team. So that you got a pair right there if you want that.